All right. So the key when you're trying to figure out what the scale factor is to take the image divided by the pre-image, right? So the transformed one divided by the original figure. And how do we know which one's which? Well, it says that you're dilating KLM to square PQRS. So this is our image right here, and then this is our pre-image over here, pre. Okay, so we take 2 divided by 3. That's all we have to do. Scale factor is equal to 2 divided by 3. All right, because the figure got smaller, our scale factor should be less than 1, right? And this is 0.6 repeating. So hopefully that all matches up with what you're thinking. The next one, the football field one, it's a little tricky. What you want to do is kind of think about it in my opinion, in corresponding parts. Like if the width of the field is 160 feet, so 160 feet, and we want to know how big is the drawing going to be in inches. Well, what are they telling us over here? That 40 feet is corresponding to 1 inch, right? So 40 feet equals 1 inch. And maybe you see, hey, look, the numerator, ignoring the units, is 40 times bigger than the denominator. So what would the denominator have to be? This is just like a look inside technique. This would have to be 40 down here, right? Because 40 times 4 would equal 160. So just a kind of a look inside technique. If you don't like that, then you can multiply both sides by x, multiply both sides by 1, and you see that, well, you don't really need to multiply by 1, but you get 40x equals 160. Let's just write a little bit of algebra out here. Then you divide by 40, and and it goes into there 4 times. What am I doing here? 4 times. Oh, shoot, I put an extra 0 on there. See, sometimes it's good to check your work. This would have to be 4 inches down here, right? Because what are we multiplying by 40 to get to 160? It's not 40, it's 4. So you end up with 4 inches, okay, on that one. So the width is 4 inches. And then you could do the same kind of thing. If I divide this by 40, kind of looking ahead here, you'd have 360 on this side. If I divide by 40, I get 9 inches. So we got something that's 4 by 9. All right. Whew. It's early. Having a hard time getting going this morning. Number 3, the dilation centered at the origin, 1, 3 to the point 412. Has what scale factor? Well, the image is 412 and the pre-image is 1, 3. So you could just take one of the two numbers, like 1, and divide it into, the corresponding number over there, and you see the scale factor is 4. It's really that easy. Like, how did 1 become 4? You're multiplying by 4. Now, let's just double check it. How did 3 become 12? We're multiplying by 4. That's the scale factor. That's all there is to it. On number 4, another kind of scale factor, but this time it's an application, right? So let's say we're going from this figure to this figure. And so that would mean that we have 3 over 4, right? So 3 over 4. And they want us to find EH, so let's put a little x here. Well, that would have to be equal to x over 8. X over 8. Now, when the variable's up in the numerator, we don't really need to get rid of this denominator underneath 3. We don't need to multiply both sides by 4, because if I multiply both sides by 8, 8 divided by 8 is 1, and so I multiply this side by 8, so 8 times 3. 8 times 3 is 24, right? So we got 24 divided by 4. That's going to give us our x. X is isolated, like solve for, 1x, right? So we get 6, because 24 divided by 4 is 6. On this one, it's really easy if you understand that they're saying A, B, C, D is similar to E, F, G, H, okay? You match up corresponding parts. So H corresponds to the 4th letter over here, because H is the 4th letter over there. So D, how big is angle D? It's 86 degrees. So the measure of angle H is 86 degrees. It's the same as D right down there. Number 6. Okay, so on this one, I had added, because on the test, it's on the test, triangle BCA, I think is right here, is similar to triangle what, right? So we got like a blank right there. And so first of all, like, what's the reason these two triangles are similar? It's called angle angle similarity. So angle, angle, similarity. And then how are the letters matched up? Well, if I go BCA, that's 61. We don't have we don't have an angle down here. We have nothing. So 61C 64, right? So I got to do the same over here. 61 nothing 64. So EFD. So EFD. We got to match up corresponding angles. Number 7. Well, here we don't have two angles over here matched with two angles over here. You might say, well, it has to be 45 up here. Well, how do we know that? I would agree, like if we had this angle down here, we could find this angle up here, but we don't have enough for angle similarity over here. But look what we do have. We have a side and a side corresponding, a side. Oh, and I told you what this side was. I wrote it on the test, right? Without that information, we wouldn't be able to do this problem. So I had a 5 1/3 sitting right here. And in fact, in third period or fourth period, I printed some new ones out, and I forgot to handwrite them on there. And so people were like, hey, I can't do this problem. You're right. You have to have a pair of sides, another pair of sides, and the included angles. So we already have the included angles. Let me put that down. Now I'm going to test to see if I have a side and a side in the same ratio. So I go 6/8. Now, see, we don't know which one's the pre-image, which one's the image, so it doesn't really matter which order I put them in. But if I go 6/8, then I got to go 4/5 1/3. Don't switch it up. 5 1/3. Don't switch up the order in which you're going. We're kind of claiming this is the image and this is the pre-image now by setting it up like this. Now, how do we know if this proportion, or if this is a proportion, if this ratio equals that ratio? One easy way is to multiply both sides by 8, get the 8 out of the denominator, and multiply both sides by 5 1/3. So in other words, we're going to multiply 8 times 4 and get 32. 5 1/3 times 6, 32. Now, some people were saying, hey, it doesn't come out to be 32, because what they were doing is instead of putting 5 1/3 into Desmos, they were putting 5.3. 5.3 is not equivalent. Okay, 5.3 is not equal to 5 1/3. Okay, so be careful. 5.3 repeating is equal to 5 1/3. So that's a very different number, right? 3. Just put as many 3s as you can fit on Desmos when you multiply times 6, and it's going to be pretty close to 32. Hopefully, it's going to be obvious. I'm not going to talk about multiplying by fractions. Get this into an improper fraction, all that stuff. But we'll just use some technology. So, what does that say? Well, we got the how would you say it? Like the including sides in the same ratio. The included angles are equal, and then the sides that are attached to that angle have the same ratios between, the image and the pre-image. All right, so down here, what do I have? I got a pair of angles, and then I got another pair of angles right here, the vertical angles. So this is definitely an angle side, or angle similarity situation, just like this one was. Although we don't have numbers down here, we have markings. Oh, I shouldn't put 1 tick here. I should put 2 ticks on that, because these were 1 ticks right here, right? We don't know that these angles are equal and those angles are equal. We know the vertical angles are equal and the ones that were marked originally, right? Now I forgot to do this on problem number 7. I have BAC down here, right? So I want you to match up the corresponding parts. Let's see, what letters correspond to BAC? So B is the one with no tick mark, 1 tick mark, 2 tick marks. So I got to go no tick marks, 1 tick mark, 2 tick marks. So D, E, C. So here we go, D, E, C. It kind of makes sense that C is in the same place, right? But if you mess up where D and E belong, that's going to be wrong. So be really careful. Over here on your test, I wrote LKJ. So let's do that real quick. Triangle LK. I don't know why my voice is cracking. Let's see here. LKJ. So I'm going no information up to this angle up here, then along the, oh boy, how are we going to do this? I guess 52-degree angle has to be the last one, right? And it's probably pretty obvious that, look, we're going RQP, right? So RQP, I hope I have that right. So no information at all up to the angle. I know we don't have any information here, but it does correspond with the 45, because then we're going along the 8 side, which we're matching up with the 6, right? Whew, hopefully that makes sense right there. Number 8. No, number 10. We have no number 9, right? So number 8 I've already done. That was the one right there. And now we're going on to number 10. All right, why are these two similar to each other? Well, the only option we have is side, side, side. And you know, what is side, side, side? That means all 3 sets of sides are in the same ratio. So we want to show that. We want to show that the smallest side in this triangle to the smallest side over here, okay, so 10 over 5, well, that ratio is 2. We can easily see that, right? And then we got 12 and 6, so okay, well, that one's 2 times bigger. And then we do the last one, 14 and 7, so 14 and 7 is 2. So that's what I mean by show ratios. And then on this one, did I have a similarity statement that I wanted you to put down? I did not. So be careful on the test. They might ask you for that. So let's practice that real quick. Let's say they said triangle CBA. Okay, CBA. You might say, well, why isn't he going in alphabetical order? Just trying to throw you off a little bit. So, because I don't know that this one's going to go in alphabetical order either, right? So CBA would go along the medium side, then along the largest side, right? So I want to do the same thing over here. Along the medium side, then along the largest side. So F-E-D, right here. F-E-D. Okay. Number 11. Let's see. There is one. Oh, geez. There is one fewer problem on the actual test than there is on this practice test. And I'm not going to tell you which one it is, but there's 12 questions on the real test, and on this test I think there were, aren't there 14? No, 13. There's 13, right? Because the numbering got out of order. Anyways, number 11. How do we do number 11? I go 3 over 2. So 3 over 2 is equal to 4 over x. Then we multiply both sides by x, multiply both sides by 2. That ends up with 6 equals 6x, doggone it. 6x equals, what am I doing? What am I doing? That equals 3x equals 8. Now I'm going to divide both sides by 3 and I get 8/3. That's my x value right here, 8/3. Boy, I might need to remake this video. My goodness. Solve for JK. Well, do you see how these two are equal to each other? And it also should say that that this is parallel, right? So if we know that these are parallel, and that's going through the midpoint right there, this segment here has to be half as much as that one. This is called the mid segment. So JK is 3.5. So there's a little bit of given information here that's missing. Or they could have said this angle right here is equal to that one right there. So hopefully somebody asked me about that in class, because I don't think everybody got to number 12 yesterday. Number 13, all corresponding parts in similar triangles are in the same ratio. So really we should say here's two similar triangles, okay? And they probably should have, you know, like you know, EGF is similar to ACB. That's probably the given information, right? So I'm going to check my test and make sure I've got that. EGF similar to triangle ACB, okay? If that's the case, then all corresponding parts, like the heights, like see, like EH is a height, so I'll call it, I'm going to call it X. But so X over 10 has to be in the same ratio as any other pair of corresponding parts, so like the same as 9 over 15. So I like to reduce if I can, so that becomes 3/5. Okay, so my fraction reduced to 3/5. We got X over 10. Multiply both sides by 10, multiply both sides by 5, or just multiply both sides by 10. And you end up with x equals 3 times 10 over 5. See, like you don't have to multiply both sides by 5. It's like an extra step. So you get 30, right? 30 divided by 5, I think that comes out to be 6, right? So hopefully I'm doing all my arithmetic correctly. My last problem, here we go. Number 14 or 13, if you're paying attention, this counting's a little off. So let's see here, IJ, I'm going to find out how big this is down here, right? And when they're, now look at this, this is good information right here. That's saying they're parallel to each other because the corresponding angles are equal. That means 2 over 1 is the same as 3.5 over x. Well, Look, the denominator is half as big as the numerator. There's a 2-to-1 relationship. So what's half of 3.5? I think it's 1.75. So we get 1.75. You're like, hey, I don't like that. I don't like just like looking inside trying to figure it out. Well, then you'd go 2x is equal to 3.5, and then you divide both sides by 2, and that's where the half of 3.5 came from, and that's 1.75. Okay? Look, on ones like this where you're looking inside, you don't really have to, in my opinion, show any work. This is your work right here. This is your setup. Okay? So your setup and then an answer is fine. You don't have to do this over here. Thanks for watching my video, everybody. I hope I made all that clear, despite being so early in the morning.